Hello, and today's purpose of the day is I can simplify complex fractions. Let's take a look at the warm-up. The directions are to simplify the following complex fractions. Let's look at the first one, 2/3 over 5/8. How would you rewrite this? Well, I would rewrite this as 2/3 divided by 5/8. And when you're dividing fractions, what do you really do? You flip the second fraction and multiply. So 2/3 times 8/5. And we could multiply straight across and get 2 times 8, which is 16, over 3 times 5, which is 15. So 16/15, which turns into 1 and 1/15. Let's look at the second example. Here we have a over b divided by c over d. Let's rewrite this to make this easier. A over b divided by c over d. And I'm really going to flip the second fraction and multiply. So I end up getting a times d over b times c, which would then be my final answer. So these fractions within a fraction, which is called a complex fraction, looks a bit more difficult than it actually is. And this is going to help us with our lesson for today. Simplifying complex fractions, day 2. Some new vocabulary. A complex fraction. A complex fraction is a fraction that has one or more fractions in the numerator or denominator. Example number 1, simplify. We have a to the 5th b divided by c squared all over a times b to the 4th all over c to the 4th. So step 1 is write it as a division problem like we did in our warm-up. I would say here a to the 5th b over c squared divided by ab to the 4th all over c to the 4th. Step 2, multiply by the reciprocal. So a to the 5th b over c squared times c to the 4th over ab to the 4th. Factor if necessary and simplify. Here we cannot factor, so what I'm going to do is I'm going to just cancel out cross products here, which would be simplifying. So I'm going to take away an a here, I'm left with 4 there. If I take away a b there, I'm left with 3 there. If I take away c squared there, I'm left with 2 there. So I end up getting a to the 4th c squared all over b cubed for my final answer here. Example number 2, simplify. So we have x plus 7 over 4 divided by x squared minus 49 all over 10. So again, step 1 says write as a division problem. So I'm going to rewrite this as x plus 7 over 4 divided by x squared minus 49 over 10. Multiply by the reciprocal, which is really flipping the second fraction and then multiplying. So here what I'm going to do then is flip the numerator and denominator, and I'm going to factor at the same time. So I end up getting x plus 7 over 4 for the first fraction times 10 over, and then here if I factor I get x minus 7 times x plus 7. And so that was the factor if necessary step. And now I'm going to cancel out any cross products or any terms that I see. And then this 4 can turn into a 2, the 10 to a 5, and now I multiply straight across, and I get 5 over 2 times x minus 7 for my final answer. Example number 3, b plus 2 over b plus 3 divided by b minus 4. So this is actually a mixed expression here in the numerator, right? Because we have a monomial plus a rational expression. So what this really looks like in the numerator is b over 1 plus 2 over b plus 3, and then divided by b minus 4 all over 1. So I need to first take care of this mixed expression before I can attempt to flip the second fraction and multiply by the reciprocal. So I'm going to get a common denominator of 1 and b plus 3, which would be b plus 3, so I'll multiply by that. So what I end up getting is I get b times b, which is b squared, plus 3b plus 2 all over b plus 3 divided by b minus 4 over 1. So I'll flip the second fraction here, and I get b squared plus 3b plus 2 all over b plus 3 times 1 over b minus 4. And that would be very helpful if I could factor and if I could see if I have any like terms or any of the same factors cancel out. So if I factor this numerator here, I get b plus 2 times b plus 1 all over b plus 3. And now I can tell that, this really is this numerator here, and nothing there will cancel out with the b minus 4. So essentially I can just multiply straight across b plus 2 times b plus 1 times this one here, and then b plus 3 times b minus 4. So my denominator will actually be b plus 3 times b minus 4, since nothing cancels out. And then that would be my final answer here for number 3. Example number 4, we need to simplify, and there's a lot going on here on number 4. I have x squared minus 4x plus 3 over x squared plus 9x plus 14 divided by x squared minus 9 over x plus 2. So I'm going to rewrite this here, and I get x squared minus 4x plus 3 all over x squared plus 9x plus 14 divided by x squared minus 9 all over x plus 2. And now I am going to flip the second fraction and multiply, and I'm going to factor here at the same time. So when I factor this numerator here, I get x minus 3 times x minus 1 all over x plus 7 times x plus 2. And again, I'm just using the diamond method to factor here. Now being multiplied by x plus 2 over x minus 3 times x plus 3, and that's a difference of squares right there. And now let's look at it and see if anything can cancel out. This x plus 3 with, or excuse me, x minus 3 with this x minus 3, x plus 2 with this x plus 2. So what I end up getting is, now multiplying straight across, x minus 1 over x plus 7 times x plus 3. And that would be my final answer. Thank you for listening, and please check Google Classroom or Schoology for more information. Have a great day. Bye.